Hello everybody, welcome to Introduction to Gaussian Splatting, which is going to be the first chapter in a very big series about the process of 3D scanning, Gaussian splatting, and how to use it in VFX for the cinema. If you heard about Gaussian splatting before, it's a very promising new technology that can offer us a lot of flexibility in VFX and compositing, and I want to explore that together with you. So also this series is going to be part of a larger series about the project that I'm working on now called Lustification. It's a short film by Leonard Leitgeb, and I'm the VFX Supervisor of this project. So we are in active pre-production right now, and Leo gave me the permission also to mention the project and to show some of the tests, and later in future video I will show you even more, so click all the links that you need below if you want to stay tuned and see all the cool things that we are going to do in this very ambitious production that I'm very excited about. So in that project we decided that we need to scan a miniature model of a spaceship in order to use it later in compositing, and we looked at a few technologies available right now, and we decided that Gaussian splatting is the way to go for us in this production. So in the past few weeks or months I did a lot of research and a lot of testing about Gaussian splatting, and I want to go with you first through the process of how to do it very basically if you haven't seen that before, and later in the video what I want to do is to show you some test results and to analyze them and to share with you some of the knowledge that I acquired from those tests, and also together to investigate where it works, where it fails, and what we as VFX artists can gain from this new technology and how we can implement that in our pipelines. So this channel is called AI for Filmmakers, and you may ask yourself, okay, what that to do with Gaussian splatting? In the process of making the Gaussian splatting is a very similar process to training an AI model. It's not exactly the same, but I find the technology very, very similar, and it's still like a brand new technology that we all try to learn right now, so I thought it will be very fitting to this channel. Okay, so let's start with my first ever test that I did, which is scanning part of my kitchen. So I just used my smartphone here, and I just took a little video of this part of the kitchen. And I thought that would be an interesting first test to do, because those surfaces, they have different textures, they have reflections and refractions, and the light is a little bit interesting there. It's not super flat light, and you see, for example, this matcha brush, it has a lot of details, and there are some writing on the caps, and all of those fine details together with all the reflections from the metal and from the other surfaces, it's something that I was very interesting to see if I can capture in Gaussian splatting. But as you can see, this shot is kind of slow, and we don't need all the frames coming out of the camera. So the first thing that I did here is to speed it up a little bit. So here in DaVinci Resolve, as you can see, the frame rate is at 300, so it's like 1000 speed. So that gives us like a very quick shot like that, which is probably even more frame than what we need. But I exported this speed up shot as an image sequence. So we are going to use RealityScan now to align the cameras from the phone footage. So it's very similar to camera tracker, like we use from compositing. So what I'm going to do now is to just like drag the PNG sequence here, and you see all the frames here, and I'm going to do the alignment by just going here above to align and press align images. And this process is going to take a little bit of time.
A few moments later.
Okay, so as you can see here on the left, we can see that out of 279 pictures, we got like 278 cameras. So it used almost all of the frames that we gave, besides one that maybe it couldn't solve, which is a very good result, I would say. Every little point here is a camera associated with a picture. And if I zoom out again, we can see the point cloud that we got out of it. Yeah, navigation in this software is a little bit of a headache, but you can see a little bit of the kitchen here represented in the point cloud. Okay, so the next step is to export that and to use it in a different software. So what we are going to do now, if we go here again to workflow and to export, I'm going to export it as a call map, and then this call map I'm going to import to the next software. So here we are in LichtFeld in English, and that's going to be the program that will take the data from RealityScan and to make the Gaussian splat on top of this. So I'm going to just drag and drop the call map here and load it. And when we zoom out, we have the point cloud, we have the cameras, and we have all the pictures associated with this. So I'm just going to run it at default right now, and you will see what happens. Okay, so it starts building all the splats around it, or from it, I should say. Let me hide the camera and the point cloud, so we can only see the splats. So what's happening right now with the process of training? It's taking those camera information and the pictures associating with them, and it tries to splat all those Gaussians around, and then he asks, is it similar to the reference frames, to the ground truth, or is it different? And if it's different, he will do another iteration and another iteration. So this is why I say it's very similar to training an AI model, because AI model is similar in the way that we compare a result to ground truth, and if it's not correct, then you do another iteration. So it's a process of machine learning by trial and error. And as you can see here on the graph on the left, is very similar to a graph that you may have seen perhaps in Nuke if you played around with Copycat, which is like a logarithmic graph that is like going down and approaching zero. And if it's approaching zero, it means that the result is similar to the ground truth. But if it's spiking up, it means that the result is a little bit more different. Then he does a little bit more iteration and run the process again. Let's start like walking around as it's training. And we can see it's already look quite nice. I wouldn't say it's good yet, but for a first test, very quickly with a phone camera, it's quite impressive. Look at the glass here, for example. We can start to see some glassy elements, and we can actually read the text also. Here we can even see through the holes. And also the reflection in the stainless steel is changing, right? The light is reacting very well to the camera position, as you would expect. Here again, we can start reading the text here, and the refraction of the glass is very good. It's exactly what you would expect. Here is a matcha thingy. Is also quite detailed, but a little bit blurry. And the same goes to other elements here in the kitchen. The only thing that really breaks, in my opinion, is the sink right now. And as you can see, as we go through time, it's getting better and better because it's continued training. And the sink is a little bit messed up. And this is something that we will investigate a little bit later in the video, because it's an issue with Gaussian splatting that is occurring quite a lot. And I will try my best to explain you why it happens and how we can avoid it. But overall, especially if you zoom out a bit, and you do this kind of thing, it looks quite nice, right? It's like quite impressive for a super, super easy test. All those splats that you see around, you would be tempted later to delete them, but we will see also later what happens when you delete them. Okay, so it's finished running. It took 5 minutes to run it. It's quite quick, and it's quite nice, right? It's quite a neat thing to have. Is it good to put on a big screen? Probably not, but it's really promising. Okay, so I want to show you another software, an alternative way to make it. So the process of making this Gaussian splat is free. LichtFeld, this software, is open source, and RealityScan that we saw before that, it's also a free software. The only catch is that you need a really strong computer to actually run those software. So in my previous PC, I couldn't do it very well, but with my new PC, with the RTX 5090 and a lot of RAM and a very good processor, you can see it's really quick and the result is quite nice. But there is another software that many people use, and I want to show you this now. So this software is called PostShot, and the free version of it, you cannot really export the Gaussian splat using other softwares. So I have here the paid version of it, and what I'm going to do right now is to do the whole process from the beginning. I'm going to import the PNG sequence, and here I'm going to go through the settings a bit, because I found that if you check this one, the photogrammic compensation, it really gives me a better result. But the rest I'm going to keep it as is, as the default, and I'm going to do the import, and it's going to do the camera tracker, and over that is going to build the Gaussian splat. So as you can see here, it's processing the information, and from my experience, this software is slower than RealityScan, but sometimes I get better result here. So I like to do both of them, both processes, just to see which one is working for the shot. And you can see that it starts building the point cloud here. And let me put the grid so it will be easier for us to see. Yeah, so it's slowly building up the cameras and the point cloud and the tracking and everything. And you can see it live here. And you will see it also shifting position a little bit. And I found that this software is not as good as aligning the scene to the origin point and to the grid. Okay, so just very quickly, it's finished all the camera alignment, and it finished making the point cloud. And what I did here is I rotated it and translated it a bit to make it like this, you know, to make it align to the grid and everything. And here we see it starts the process of Gaussian splatting. And it changed everything again, so I need to realign it again. So this is something a little bit annoying about this software, but let's see how it builds the Gaussian splat. Okay, so it's finished doing the Gaussian splat. Now let's have a little look. And it looks nice. It looks very similar to what we had before. In some areas it's doing a little bit of a better job, like having fine details here. And in some part it's doing a worse job, like here in the sink, for example. You see it's breaking a little bit more, or when we look at it from the other side. So this is why I think it's important when we work with Gaussian splatting that to try different approaches and different software and to see what works best for us. The next step here is to export this as a PLY file, and I will meet you in the next software. So this is Super Splat Editor, and this is a web application, so you don't need to download it, it's running on your browser. To this software, I'm just going to drag the PLY file that we exported, and we can zoom out and see the splat. And as you can see, it's running on my browser really nicely, really fast. So that's one of the benefits of Gaussian splatting, that it's really fast to run. Even on a laptop, you can run it at very similar speed. It's not that I have a monster computer and this is why it's so fast. And this is also why this technology is so appealing right now to use. But what we can do now here in this software, first is to take a measurement. And I always like to start with this, and I can measure this part, for example. Yeah, and I know that this is, let's say, 50 centimeters. Here it's in meters, so I will do 0.5. And you can see it's getting smaller to the correct size that it's supposed to be. And from now it's going to be just much easier to start cleaning it up, because as you can see when we zoom out, we see all those other splats around. And if you take a look here below, you can see we have 2 million splats, and maybe we can reduce it even more to make it even quicker to work with. So let me just do a very quick cleanup. All right, as you have seen, I selected only the central part, and then I inverted the selection, and now I separated that. And if I check this eye here, we can see only the middle part. So that's a very fast cleanup, and here we can start see some more issues, because those other splats that we had in the background, actually they had some kind of purpose, you see, because now, for example, in the wall, we can see a lot of holes. You can see all those black things in the wall, right? So there used to be like white splats in the background that kind of covered it. And this is one of the issues that I found that is very, very annoying with this technology, that you get all those random splats that you need to keep because you want that. But then if you start adding splats together and you start building something bigger, then they start to collide with each other and you get a lot of messy artifacts. And here, for example, you can see another very big hole. Overall, we still get the main focus here working somewhat. I mean, it's not perfect, but we also reduced here from 2 million to only 200,000. So another tool that is nice to use here is the brush tool. So we can see here some more floaters. So I can just like select those floaters here with a brush. You know, I don't want all those splats here. And then I can just delete it. And then I can rotate the camera again, select some more, and delete it. When I'm happy with the result here in Super Splat, what I would do usually is just export another PLY file from here, and then I can import it back into Nuke, because Nuke now has the features that it can read Gaussian splats. And this is why it's so appealing to use now in compositing in VFX, because we can start making volumetric plates. And this is a term that I heard Alex Villabon is using, which I think is very clever, because if, for example, we have a green screen scene and we have some camera movement and we need the background also to move accordingly, to model the entire thing and to do all the textures and to put all the lights there, it's kind of a lot of work, especially for an indie production like the one that I'm working on right now. And from a very quick test with a phone camera to get a result like that is very promising and it's very exciting. Here we can see another example that I did with the same phone camera, but now I'm in my shower and I used a lot of my shower in those tests because in my shower I have very bright light and also it's a very small space. And in that production I will need to scan the interior of the model, which it's big enough for me to get inside and get a scan, but it's not like real size spaceship, right? So I figure out the shower is quite a good one. And as you can see here, the plants and the water, they look quite nice. I really like this result. And it's only made with a phone camera, right? Look at all the petioles of the plants and all the flowers of the orchid. It's really nice. And it captures also all of the details from those leaves. So I was really surprised to see what I consider quite a good result for a super quick test with a phone camera. If we can zoom into the glass, we can see the writing on the glass, and we can see some reflection and refraction from the liquid inside the glass. And also you can see on the leaf, when I move the camera around, how the light is changing on the surface of the leaf, right? And it really looks photorealistic. Okay, so if I can get this result from a super easy test with my phone camera, what can I get with a good camera? Okay, so the first camera I tested is the Sony 7R2 that has a lot of megapixels and a full frame sensor. And I took this shot of the bike outside of my home. And as you can see, I'm just like walking around the bike a few times, shooting it from a few heights. In Super Splat, the result is like that, which is really cool when you look at it from afar. But when you start looking at it closely, it actually has many issues. You see, it doesn't have like a really high quality to the bike. So I wasn't really happy with that. Another thing is that I found that with a full frame camera is that there is a lot of vignetting around the frame and some lens distortion, and I had to compensate for that manually to get a better result, because I even got a worse result than that. So to compensate for the vignetting is not so easy as you may think. Like if you want to do it properly, what you need to do is to do flat frames, which is a term from astrophotography. If some of you played with astrophotography, you know that a flat frame is a frame that you shine light into the lens, or you take a picture of something really bright and flat without any details, and it captures all the light distortion that is happening inside the lens and the sensor, like the vignette. And you take this frame and you divide it by the footage that you take, and that's supposed to remove the vignette from the frame. It's not so straightforward as what I described. There is a lot of things to tweak there, and also to fix the lens distortion, what you need to do is to take a picture of the grid, and then in Nuke or other software you need to solve this lens distortion grid, and then you reapply it, and then you need to export the frames again. So there are like 2 more extra steps to do to get a result which is kind of mediocre. I don't think that you need a very high resolution camera to do that, because if we talk again with like the language of astrophotography, there is something called image stacking. So in astrophotography, you stack a lot of frames together, and from that you get a much better result overall. So the SNR, the signal to noise ratio, is getting higher and higher the more frames you stack together. And a similar thing I think is happening with Gaussian splatting, very differently, but because there are many frames to add together and to 3-dimensionally assemble together this Gaussian splat, there is no need to go really crazy with resolution. I think what's more important is like the quality of the images should be consistent to each other, so you must shoot at manual. And also I learned from this test that actually the full frame sensor with some depth of field is not good, because the thing that really breaks Gaussian splatting is when some areas are out of focus or less detailed, and camera shadows. So when some parts of the frames are out of focus, for example, it can really mess up the solve of the situation. So I decided a smaller sensor is actually better, because with smaller sensor you get a much wider depth of field. But the problem with the cameras that has small sensors is that the images are more compressed. So you don't have the depth of field blurriness, but you have the compression blurriness. So the second camera that I tested is the DJI Osmo, which is a tiny little camera on a little gimbal. And I just scanned my lunch here, as you can see, this sandwich. And I just did that, like on top of it, as you can see in the video, and I capture all those cool little pictures. It's like a drone flying above the sandwich. I did all the processing, and the result is like that, which is kind of cool, right? It has some issues with the reflections here, but only when you get really close you can see that. If I show you the background, as you can see, there are more issues from things around it, like the matcha latte here looks really bad, and the Game Boy looks bad, and only the sandwich, which is the object that I was focused on, looking quite nice. The issues with this camera is that, like I told you, the small sensor cameras tend to have higher compression, so the periphery of the frames, or the things that are not very detailed, got smeared out, and the result got really muddy because of that. This is why all the things around the sandwich are so muddy, and also part of the sandwich itself and the reflections, they have this like muddy textures to them. I believe this is mostly because of the compression of the camera. And by the way, I only show you like a few examples that I did, but in total I did many more tests. I did in like over 20 tests of all the cameras. And the conclusions that I come to, maybe you don't see it right now, but you need to trust me, bro, because I did do a lot of testing. So just for the record, like for example, here it's very obvious to see that, you know, this part of the frame of the table is really blurry, but here it's a little bit better. And I believe this is happening because of the compression, and some parts of the frame are more compressed than others. So the next camera that I tested is the GoPro 13 Black. And here I will show you a test that is more relevant to the productions that I'm working with right now. The spaceship model is going to be built from some materials, and the art director Tizian, he gave me those materials, the light fixtures and some plastic element, to scan and see if it works. You can see here one, that's another material, and I scanned it on my bed because I had good lighting there, and that's another material, this box. So we were very curious to see if we get any kind of moire effects and stuff like that with the scan. So this is all captured with the GoPro, which has a small sensor, but I used very high settings on the GoPro because I think like what really works well with the GoPro is that it gives you the option to capture high quality image with a very small sensor. And also the lens is quite wide, and the automatic stabilization with the GoPro also worked very well in this example. So I can tell you overall from all the cameras that I tested until today, I got the best result out of the GoPro. But let's look at the result in Super Splat. Okay, so I just did a separate Gaussian splat to each element, and I add them all together into one PLY file. So this is what we are looking at now. So we can see that the plastic, first of all, it has some holes in it because we can see the grid behind. So for this example, I will going to remove the grid, so it will be easier to watch. The problem with the hole is the same reason of the holes that we saw in the sink before in the early example. When you have a smooth surface like this black plastic or a white wall or a stainless steel sink, what happens is that it's very hard for the software to estimate the 3D shape of the thing. And like when it constructs the point cloud or the Gaussian splat, it can decide it's not a flat surface, it's actually something in the background and there is a hole there. So this is quite a big issue, but for now we are going to ignore it. I will discuss with you the solution for this later. I really like how the light changes here with the plastic. It's reacting very well. And let's go to the next material here. So here I was really surprised to see all the fine details with the textured clear plastic, because this plastic is not very smooth. It has a little bit of texture to it, and it actually goes through it. It doesn't look like a clear plastic, it looks like a rough plastic, which is very good. And also very good light behavior. That's just the plastic without the wire mesh behind it. And as you can see, the result here is worse because, again, when you have a clear surface, a flat surface, a single color without texture, it kind of confuses it. And you can see when I go to the side, it really breaks a bit. But contrary to that, look at the box. I think this is a very good result of the box here, because the box has a lot of fine details and a lot of texture, and only here when we can look at this like flat area, this is maybe breaking a little bit, but it's not such a big problem like with the other one. What I really like about the box, if you look here, you can see like a little bit like halation effect there, right? With the light coming behind. And I think maybe the GoPro camera is kind of doing that, and it shows in the Gaussian splat. So that's a really nice result in my opinion. There is no weird moire effect, and overall I must say that I'm quite happy with the result of the GoPro 13 Black. The biggest problem with doing a Gaussian splat in the approach that I showed you, to take a camera and then to solve for camera tracking and then to estimate a point cloud from that and then to estimate the Gaussian splat, it's all estimation. It's not really real information, right? It's just like very fancy algorithms that are estimating where the camera is supposed to be and how the shape's supposed to be in 3D. And this is why we see like flat surfaces breaking, and this is why we can see all the other issues that we discussed before. And the only solution, if you want to do a very good Gaussian splat, you can have like the best camera, the best gimbal, the best solve. It will never be as good as if you use a LiDAR sensor. And cameras that have LiDAR sensors that are dedicated to do stuff like that, like 3D scanning and Gaussian splatting, they're relatively new to the market, and they're still quite expensive, because most of the use cases for doing scans like that, it's actually not for film yet. People use it mostly in real estate when they want to scan an apartment or a building and then sell it to a client or to put on their portfolio on the website, or in construction sites when they need to monitor it from afar, so they would do a scan. But if we want to use it in film and we don't have a huge budget to do it right now because it's an indie film or something, we cannot afford those really expensive cameras right now because they're not so available. The rental companies don't have them yet, or there is no demand for the rental company to purchase a camera like that. So I came across this camera, which is the first camera in the market, as far as I know, that is dedicated to making Gaussian splat. So it's called the PortalCam from XGRID, which is a Chinese company. If you scroll down and you see the tests and everything, the result is very, very good. Even if you go to Super Splat, you can see other people uploaded their Gaussian splat into this website and you can explore it yourself. And all the tests that other people did that I saw that are made with this camera, they all look like really, really good. It's really, in my opinion, right now, the only viable solution if we want to do a Gaussian splat of the set, of the scene, of something that we want later to use in something like Nuke for compositing. So I cannot tell you right now exactly what we are going to do on set. You will need to follow me for that because it's still an ongoing process of discovery with this new technology, but I'm very excited to explore it, and I learned a lot through the tests that I did in the past months. If you have any insight, if you worked with Gaussian splatting before in compositing and VFX, please write a comment and tell me what you think about it. I feel like that can really revolutionize a lot of like green screen workflows and 3D workflows. And I'm really excited to work with this new technology on this project. And those are kind of like my conclusion and my thoughts about Gaussian splatting. This is why just like an introduction video. Later in the future, I will do a more in-depth videos when I have like real footage from the set to show you, and we'll walk through it and I will show you exactly how it works. And also in compositing, how we can integrate it into our workflow. So please stay tuned and I will see you in the next one. Bye-bye.